Number one, we're going to be using two different ways to simplify 240 over 540. So using the GCF, we're going to have the ladder method that we'll be using to find the GCF. So 10 goes into both these numbers. We're going to divide that by 10. And these two numbers are also, they're divisible by 2 because we look at the 4 in the ones place. So we'll get 12 and then 54 divided by 2. 14, that goes 7 times, so 27. And these can both be divided by 3. So we got our GCF factors. You multiply them together, and you get 60 as our GCF. So the greatest common factor that we can reduce this huge number by is 60. And we already did it in this ladder method, and we know it's going to equal 4/9. So using the Euclidean algorithm, we didn't know that this was going to be the greatest factor. We didn't know if it was going to simplify. So we will start with the biggest number out of the numerator and denominator. How many groups of 240 go into this bigger number? Well, 2, most likely. Let's see if that works. 480, yep, we can't go bigger than that. So we get 60 in the end remaining. We get 2 groups plus 60 remaining. Now we're going to bring this number and see how many groups of 60 go into 240. Well, 4 plus 0 because there's none remaining. That's equivalent. And so we know this is going to be our GCF. And there's no remaining, so that's why there's a GCF of that, which we know what to do from here is divide by 60 and get our same answer of 4/9. For number 2, finding the least common multiple of these two numbers, fractions, we're going to find a common denominator this way using the ladder method. So dividing these two numbers by 3, we get 8 and 10. We can divide this further by 2. Now our factors multiplied together are going to give us our least common multiple. So this will be 120 as our least common multiple, which also becomes our LCD because we're talking about fractions, and we can have our LCD be the denominator as well. So 11 over 24 times 5 is going to give us 55 over 120. And how I got this was 3 times 2 times 4 gives us 24, and the only one left factor-wise was 5. So I knew I had to multiply it by 5. Our next fraction, we're going to be multiplying by 4 to get 120 on the denominator and to find 52 to be our numerator. This fraction is bigger, and our simplified version of this is 11 over 24. So we know that 11 over 24 is bigger than 1330. Finding the easiest common denominator is going to be very quicker, but with a larger number. So we're literally going to multiply the two denominators together to find our ECD. Which you're going to get 720 as our ECD. So 1124 times 30, 330 over 720, and 1330 times 24, getting our ECD. So 13 times 24, we get 6, 260, 312. So out of these two fractions, we have 330 over 720, which is simplified to 11 over 24, which is greater than this fraction, which is a simplified version of this fraction. For number 3, we're going to be simplifying this fraction. And in order to do so, we're going to use the order of operations. So this fraction bar is actually the same as saying this group of 3/5 plus 1/3, parentheses, grouping, is divided by the group on the denominator, 4/5 minus 1/10. And so, on the side, we're going to find a common denominator, 9 over 15 plus 5 over 15, which is equivalent to 14 over 15. So this is 14 over 15 divided by 10. Common denominator, we get 7/10 is this group. And so this is the same as saying 14/15 is multiplied by 10/7. And we're going to simplify this as much as we can to get 4/3 as our simplified answer. To convert for number 4, this number to a fraction, we're going to start by letting n equal this number, which means that n also equals 3.573212121 and so forth. And now if we multiply both sides by 1,000, we will get 12121. And see how the decimal, after the decimal, it's 21221 repeating? Well, we want to cancel that part out, and so we also want to get another equivalent another number that would have 21221 on the right side. We can't do 10,000 because there's two numbers that are repeating, not one. So we can do 100,000 to move it 2 decimal places. We're going to use these two numbers now. 2122121. Subtract it by 1,000 in, and we have 35732122121. Okay, we can cancel out this side now because this is the same, just like 1 minus 1 equals 0. And now we're going to subtract 99,000. So now divide each side by 99,000 in order to get n by itself so that we know what the equivalent fraction is. And this is an unsimplified version of the repeating decimal. Okay, for number 5, we start with 1.3. What is this in fraction form? Well, if we want that in a fraction, that's the same as saying 1.3 over 1. Now if we multiply this by 10/10 to get rid of the decimal, we will get 13/10. Now 13/10 in a percentage, what is that? Well, we need to multiply it by 10/10 in order to get the fraction over 100, because anything over 100 is going to give us our percent, 130%. And then 130% into a fraction, we know that's 130 over 100 by definition. Reduce it to get 13/10. We have the same fraction. Now say we start with 5/6, and we want to change that into first the decimal. Well, let's figure that out through division, dividing this numerator over the denominator. 6 goes into 50 up to 9 times. Drop the 0 again 9 times. And then again 9 times, and we know this is gonna repeat, sorry. 45 should be a 5. And so forth. It's 50 again. We're going to still get the repeating decimal here. So we know it's equal to 0.999999999 and so forth. Now 0.9999999, we're going to round it to approximately 0.9999. We want to round this, which rounds this one, which rounds this one, place value wise, to get equivalent to 1.000. We're rounding to the thousandths place. And then 1.000, we want to change that to a percentage. Well, that's the same as doing this. Multiply that by 100 to get our percent, and we have 100 over 100, which is equivalent to 100%. And 100% is 100 over 100 by definition, which is equivalent to reduce to 1 over 1, which is not the same fraction as what we started with because we rounded.